So this is Greg Trauthwein. I'm with Maritime Reporter TV, and we're very pleased to be here today with Dominik Schneiter, VP of R&D of WinGD, and Volkmar, Global Sales Director of Sales with WinGD. And can you share with me the greatest lessons learned from those 550,000 hours of operation since this engine's been in operation?
Biggest learning is with such a new concept, with the low pressure on two-stroke engines, you face teething problems. And luckily, it was technical problems which have been possible to solve and not concept problems. Because in the beginning, as we have heard from the market said, oh yeah, this low pressure thing on the two-stroke engine will never work, because they have knocking and they have misfiring, and it's so difficult to control the engine, they will never control the combustion process. And the biggest learning here is that the combustion process is pretty stable, and we have it completely under control.
We have a track record of between 95 and 98% of operation time on gas. This is particular on LNG carriers. They really just switch to diesel fuel when they have to, according to IGF code. This is for maneuvering. There is once a week they run shortly on diesel to make sure the injection system, the liquid fuel injection system, is not blocking or so. But beside of that, they really operate on gas. And I mean, such a high utilization of the gas system is pretty unique as well, and can be discussed a bit more. But that shows that actually the technology is very reliable and manageable on board. Teething problem Volkmar was mentioning to our I wouldn't say normal problem, but problems that we have somehow also expected. We had, for example, leakages, water leakages from the breech chamber. After 5,000-6,000 operation hour, the bolts holding down the breech chamber got a bit too weak. They were kind of overloaded with the time. And then we started to develop water leaking into the cylinder. And this, of course, is not very nice for piston running. So we had some piston running issues. Another big lessons learned was related to the cylinder lubrication oil itself. Actually, we had deposit buildups. This LNG burning engine, and there we cannot differentiate between low pressure and high pressure cycles. They seem to develop rather high deposit buildup, particularly if the ship owners use higher BN numbers. And we have realized also in CMAQ working groups, for example, that the cylinder lubrication developed for HFO and MDO applications are not necessarily the best oil for LNG application. But this is addressed with the oil industry, the suppliers of these oils, and one after another comes now with good and good matching oils for such LNG application.
Can you give me an overview of the research facilities or the R&D facilities that you have?
Mm-hmm.
Yeah, very good question. Thank you. We actually have invested heavily in our testing infrastructure, and I think that's impressive also to see. We run several test rigs. I start here with the spray combustion chamber, a constant pressure chamber, which actually is used to investigate fuels, whether it's HFO, traditional heavy fuel oil, other diesel-like fuels, but also the new biofuels. For example, we tested already several different types of biofuels, also diesel-like fuels derived from biomass. And we plan now to extend these tests also to of course, the new fuels coming. We have already tested ethanol as an example, also for methanol, for the alcohols. And this spray combustion chamber can be used for any of the fuels coming, whether they are burned in a premixed Otto cycle mode or in a diesel cycle diffusion mode. Then adding on that, we have built and invested into a single cylinder research engine, which is currently being started in China. So this engine is actually planned to be the intermediate step between the spray combustion chambers and then the multi-cylinder engine test engines or field test engines. So it's really an engine in place to research the new fuels coming, in addition to also combine these engines with for example, for intelligence, smart system that evaluate the combustion online in real time, model based, but also artificial intelligence, somehow data based. we come up with some hybrid system also here on the intelligence side. In China, we have 2 multi-cylinder engines new. They are called Arctic 7, Arctic 8, which are standing on our sister company, CSPI, in Shanghai. There we build up now the entire test team. So they will also do research for us, technology research. Currently, they work on one engine. Fundamentally, one engine is for Otto cycle development and the other engine is for diesel cycle development.
Obviously, it was the introduction of the X-DF2.0 and the introduction of the iCER technology. So as a ship owner, why would I be interested in iCER technology? What is iCER technology and what's it going to do for me?
Yeah, that's a good question, because you should ask the ship owners.
I will.
But because we get the same question from the ship owner saying that we want to have a methane emissions reduction possibility with the low pressure dual fuel engines. We see that more and more ship owners are looking into the greenhouse gases, even if it's not regulated at the moment, but it might be in the future. And as the cut of the methane emissions is also, let's say, in our focus, not only because of the methane, but also due to the performance focus we have to make the engines more efficient, as we have somehow described in the webinar. Maybe Dominik can add on later, but with this new technology, we can increase the compression ratio. With that, we can also reduce the consumption. So that is, of course, a driving factor for us, because the better the consumption, the less emissions, and of course that's good for the ship owners. And we have with the first tests coming to this number 3% reduction and in gas and 5% reduction in liquid mode, and also on top 50% reduction on methane slip. That is somehow the request from the market to reduce the methane slip, and I'm really wondering what is the driving factor behind that on the ship owner? Is it just his mindset that he wants to have a better footprint? Is it container vessel liners? They need an image to be green, because the consumer at the end is wanting that his shirt or whatever car is delivered with a less footprint on emissions. So it's a very holistic view we have to see there, or holistic approach we have to see there. But we of course see the demand from the ship owners who are advanced, and they want to reduce the emissions, and of course have a better operation and expenditures on fuel consumption.
And this iCER technology really allows to control the combustion nicely by replacing oxygen with CO2, as introduced in the webinar earlier. And therefore we can modulate actually the combustion very nicely and go closer to limits. And we do not have early ignitions. We don't reach this rich limit so early. We have a slightly slower combustion, or with other words, we can control the combustion speed and therefore have the optimal pressure working on the piston, and with that create the optimal torque to the engine.
Where will you be looking to make improvements next?
The other point here is clear that as we have somehow tried to outline, that this iCER technology is, let's put it this way, the X-DF2.0 is somehow a concept, and it is the new engine generation for low pressure dual fuel. We start with the iCER, and as we have, let's say, published at CIMA conference with the VCR, the variable compression ratio will be the next step of technology to somehow be incorporated. It's very, very early stage. So that is a technology we need to somehow also align the development of the X fuel or the next fuel. Because what we have to do now is we need to be, what Dominik explained here is, with all this test setup and the capabilities we have, we need to set up a field here to be very flexible, because we need to see that you can describe much better than I can, Dominik, but we need to see the combustion behavior. We need to see what kind of fuel is coming, what is the characteristics of these fuels. We need to really investigate into this fuel, whatever fuel it is.
I think important to understand is that we see the internal combustion engine not part of a problem, but part of the solution. And of course, this goes through the new fuel. So we see actually the two-stroke low-speed engine also in 2050 still being the solution to propel vessels. But of course, we also carefully observe what else is going on in the industry, in related industry, and also other industries. And we see actually that the system integration, hybridization abroad, electrification, that will for sure come as a first bigger step. Volkmar had this in his slides today, showing a bit the steps to 2050. And the two-stroke engine, even it's quite a static machine, it's a combustion engine with cycles, and we know how to deal with the dynamics of these engines. And if we combine that with other energy consumers and sources like PTIs, PTOs, batteries, smart management systems, we see there still a bit, quite a big potential. We talk about 10 to 20% higher energy efficiency in a total propulsion pack. And this is just without discussing the fuel. And now when we start to discuss the fuel, I think it's important to know that everybody seems to count a little bit on synthetic fuel. So it's high synthetic hydrogen that is then derived, either used as hydrogen, which is very cost intense because of the cooling down and the storage. Liquid synthetic methane, so what we have actually, LNG, but also ammonia as a derivate, the methanol as a derivate, the alcohols, all these fuels, they count on sufficient renewable power to produce this hydrogen. And actually the studies just show that we have to correct the predictions of renewable electricity generation by 25-30% upwards to make enough renewable electricity available to also power the marine fleet. So that seems to be a major challenge, and needs major incentives from policymakers to make enough electricity available to produce such synthetic fuel. So in my view, we should not neglect too much also the biomass sources. Of course, nobody likes to discuss really or take this up, because you might very fast interfere with your food chain, your crops and fibers, etc. But if you find a sufficient biomass sources from waste products, from forestry waste products, or from aqueous water sources, ocean sources, I think there we have a combination where there might be sufficient fuel available. And again, LNG is a perfect bridging fuel, because particularly if you start to look in biomass, agricultural sources, methane is there already, and you just need to capture it somehow and re-liquefy it and make it available to bunker on the current LNG ships. So the infrastructure would be in place on board, but also ashore.
As you both know, with new technology comes new maintenance issues. When you're looking at the new iCER technology, is there any maintenance protocols or guidance?
Yes, of course, it's in place. You have to understand the equipment used for the iCER is mainly, on a big extent, off-the-shelf equipment now in the development project from Alfa Laval. So it's nothing extraordinary. It's a water treatment or water circulation system with a back cooling. It's a cooling tower, so to say, with the spray that cools the exhaust gas. And accordingly, the maintenance process, the class approval of this part of the system, they're all available. It's tested and used many times already in the marine industry. What we did, we just applied it now for a different purpose. For this, at the end, we have to admit, it's an exhaust recirculation system where we bring the exhaust gas back to the combustion chamber. And even the turbocharger, axial inlet, which you need, is also quite proven already, because it's the same system as we use for high pressure SCR application on board the ships with tier 3 measures. For the engine itself, to complete, the engine is a standard X-DF engine that is just modified by the tuning. So that means mainly different software parameters and of course the higher compression, which we were talking about. So the engine itself, the base engine, is exactly the same as the X-DF engines already in the market.